Alright guys, so I'm going to go ahead and make a couple of videos this time and see how these work. The first one is proving a quadrilateral is a parallelogram. So piggybacking off of last week's notes, it says if both pairs of opposite sides are parallel, then a quadrilateral is a parallelogram by definition. We also have a few other ways that we can determine if a quadrilateral is a parallelogram. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Diagonals bisect each other, and one pair of opposite sides are parallel and congruent. So that gives us a few options moving forward. Alright, so our first set of examples is, can you determine if the following quadrilaterals are parallelograms, and we want to be able to justify our answer. So looking right here, if I take 68, and 112 and add those together, that's going to be 16, that's going to be 18, and then that's what, 12, 13, 14, so that's 114 degrees. No, 200, it's early. Yeah, 248 degrees. We know that a quadrilateral has 360 degrees. So if I take 360 and I subtract 248 from that, I'm going to wind up with 112. So I know that that's congruent to this one. I know that this one is congruent to this one. And so in this instance, I know that both pairs of opposite angles are congruent. So in this case, I can say yes. So yes, because both pairs of opposite angles are congruent. Okay, so right here, I don't have enough information to find these. Plus, if we remember from last time, consecutive angles needed to be supplementary, so they had to add up to 180. If I take 107 and 70, I get 177. That's not going to work. So in this case, I would say no. Alright, moving on. So, talking about diagonals. So right here, diagonals bisect each other. Okay? So that's congruent to that, and this is congruent to this. So in this instance, because the two diagonals create, or well, since the diagonals cut each other in half, yes. So this is yes, because diagonals bisect each other. Here, they don't. So this would be no. Okay. So can you determine if each of the following quadrilaterals can be parallelograms? Justify your answer. Right here I have one pair of opposite sides that are. I don't know about these, nor do I know if anything is parallel. So this one is no. Right here, this one will be yes, because both pairs of opposite sides are congruent. Okay, so right here I know that that's parallel to that. The problem is they're not congruent, so it's going to be no. Right here, both of them are congruent. They're also parallel, so this is yes, because one pair of opposite sides are both congruent and parallel. Alright, moving forward. Alright, so it says find the value of W that would make the quadrilateral a parallelogram. So I know that these are congruent to each other, which then means I need to also know that this is going to be congruent to this. So I can take 3W, set it equal to W plus 36, and I can find W. So we'll subtract W from both sides. That gives me 2W equals 36. Divide by 2, and W is going to be equal to 18. Alright, so again, find the value of P that would make the quadrilateral a parallelogram. So again, those are congruent, so then this side must be congruent to this side for it to be a parallelogram. So 8P is set equal to P plus 28. So subtract P gives me 7P equals 28, divide by 7, and P is equal to 4. Alright, so it says if SV, so SV, that's this part here, is B minus 32, and UV, which is this part here, is 2B minus 86, find the value of B that makes quadrilateral RSTU a parallelogram. So remember, diagonals must bisect each other, so that's congruent to that, which means this must be congruent to this. So again, like the other two examples, we're going to set them equal to each other. So that's B minus 32 equals 2B minus 86. So subtract B gives me B minus 86 is equal to negative 32. We're going to add 86, so B in this instance is going to be equal to 54. Okay, I hope the explanation helps a little bit more than just the video itself. Good job working, and I really miss being in class, guys. So we'll see you guys later.